So we talked about the advantages of using vertex form, being that finding the vertex was very simple with vertex form. Standard form, graphing standard form, very similar in that we're going to try and find the exact same points. We're trying to use the vertex, we're going to find the roots, we're going to find the y-intercept. The problem is what's most difficult about standard form is that we don't have those transformations visible to us. We don't know what h and k are. We don't know how much did the graph move right, how much did the graph move left, how much did the graph move up or down. Actually, none of these numbers, A, B, and C, don't tell you right, left, anything about the translations. They don't tell you how much your graph has moved in any way. In any way, we talked about that A could tell you whether your graph is opening up or opening down, but again, we don't know right, left. We don't know anything about the vertex. So finding the vertex actually becomes a little more involved here. And the way we find the vertex is there's actually a little bit of a formula that tells you the x-coordinate and the y-coordinate. If we want to know the x-coordinate of the vertex, the x-coordinate is equal to, it's negative the b value, whatever the b value is, over 2a. If you think about the quadratic formula, negative b plus or minus square root of b squared minus 4ac over 2a, it's kind of like it's just the beginning portion of the quadratic formula. So find the x-coordinate using negative b over 2a, and then to find the y equals, you plug in that x value. So we plug in that x value to the equation to figure out what the vertex is. The roots, we find the same way we did before. The roots end up being, you use factoring for the quadratic formula. And the y-intercept, same way as before, you want to plug in 0 for x to figure out what the to figure out where the graph crosses the y-axis. So if we actually put this into play, the new thing, the only new piece is that we can't find the vertex using the translations. We have to use negative b over 2a and plug in your x value to find the y value. So if we're looking at graphing this equation, y equals negative x squared minus 2x plus 1, we really are going to have to use, in each case here, our a, our b, our c value. So finding the vertex, we want to take negative our b value over 2 times a. So this will be 2 over negative 2. Our vertex, our x-coordinate, is negative 1. To figure out the y-coordinate, we just need to plug that value in for x. So we're going to plug it into the equation. Y equals negative. Plug in negative 1. Remember when you plug something in, put it in parentheses. Substituting in means you need to put it in parentheses. Negative 1 in for x, and plus 1. So y equals, this is negative. Negative 1 squared is 1. So negative 1 would be, so this would be positive 1. Stick the negative sign on front. Negative 2 times negative 1 is positive 2. And then plus 1 on the end. So negative 1 plus 2 plus 1 is positive 2. Our vertex is at negative 1, comma 2. So if we graph that, negative 1, comma 2. We draw in our axis of symmetry. You're kind of trying to figure out here, okay, well, where is my graph going to go? Is it going to be a parabola like this? Is it going to be a parabola facing downward? Remember, you can look at the a value. The a value tells you if it's negative, which in this case it is, that means it's opening down. It's flipped over translation is, or its transformation is, that it's flipped over the x-axis, so that means it's going to be facing opening downward. So negative means it's going to be opening down, so our graph is going to be facing downward. To figure out the roots here, factor or use the quadratic formula. In this case, I'm going to suggest to use the quadratic formula. So I'm going to pause it, write out the quadratic formula just to save time. You might want to pause it here and practice using the quadratic formula for yourself. So if you look, we have the quadratic formula. Negative b value is negative 2 plus or minus square root of b squared minus 4ac, so a was negative 1, c is positive 1, over 2 times a. So if we simplify what's in the square root, that's 4 plus 4. The negatives all cancel out. So that works out to be the square root of 8. Negative 2 became positive 2, and 2 times negative 1 became negative 2. So if you take 2 plus the square root of 8 divided by negative 2, you get the first answer here, negative 2.4. If you take 2 minus the square root of 8 divided by negative 2, you get this 0.4. So this positive 0.4. So that we graph those, I mean, we're going to only be able to approximate where they go. But if you notice, like we were talking about, the axis of symmetry is a good guide. Sorry, hit a button there. But if you look at the axis of symmetry, there, it gives you a good, where if you put your roots on, kind of approximating where they belong, they look pretty evenly distributed on both sides of the page, or both sides of the axis of symmetry. The y-intercept, this is where I said there was going to be a little bit of an easier thing to find in our standard form, is when if you plug in 0 into x here for this equation, negative 0 squared minus 2 times 0 plus 1. The nice thing that happens when you have an equation in standard form is, what happens with these zeros? Well, that cancels out, that cancels out. The y-intercept is always equal to your c value, so I'll write that up at the top. This c value, when you're writing it in standard form, your y-intercept is always going to be equal to that number. So our y-intercept is 0, 1. If I wanted to, because I know this axis of symmetry reflects on both sides of the line, I know the point 0, 1's on there. I could also reflect that point. So in this case, it works out to be a really nice number. It's at negative 2, 1, to give me a slightly better picture. Just easier to connect more dots. So if we're looking at the domain, negative infinity to infinity, the range, in this case, we're talking about lowest value comes first. Our graph continues down and down and down forever. The highest value that the range goes to would be, it looks like we only go up to positive 2. So the roots are just as involved as before, but maybe the vertex is a little bit more work. So the nice thing about vertex form was that it did kind of cut out that extra work. So take a second, I would say pause this video here and see if you can come up with the same values that I do for vertex, roots, y-intercept. In this case, I'm going to give you a hint. Remember, for the roots, you can factor a quadratic formula. In this case, you can factor. So always look for the easiest way first. But I would say pause it and then check out the answers in a minute. So the vertex here, negative your b value over 2 times your a value is 1 in this case. There's no number in front of there. So negative 4 divided by 2 is negative 2. When we plug that in, negative 2 squared plus 4 times negative 2 plus 3. That's 4 minus 8 plus 3. That gives you a vertex of negative 2, negative 1. Negative 2 and negative 1. If we're looking at the roots, if I'm going to factor, plug in 0 for y and then see if I can factor this. I say what multiplies to be positive 3 and adds to be 4, positive 4. Well, 1 and 3 would work. So this ends up being factored as x plus 1, x plus 3. So that means my x-intercepts, if I take each of these and equal them to 0, my x-intercepts are negative 1 and negative 3. What makes each of those parentheses equal to 0? Well, negative 3 works, but also negative 1 works. So there's my two intercepts, my two x-intercepts. The y-intercept is the c value. The c value in this case is 3, so 0, 3. And again, if I draw in my axis of symmetry through the vertex, I can reflect that. It's 2 spaces away. I can reflect that to the other side to give me just a slightly better picture. So I have my points, and now I can graph my parabola pretty well. Domain, you'll notice on all of these, our domain is going to always be the same. The range is what's going to change. So it's lowest it goes to the highest it goes. -1 to infinity. So one of these problems, one of these two, I'll take a piece out of for the video quiz tomorrow. We'll practice this in class as well. Have a good rest of your day.